I bet you've always wanted to know about dirt. Well, if you have, today is your lucky day. Because in this presentation, I will be discussing soil and vegetation in North Texas, specifically in the Denton area. I will talk about how different textures of soil determine what type of plants are able to grow, and I'll also look into how weathering over long periods of time creates different types of soil and what that can tell us about the area's past. Lastly, I'll go over soil taxonomy, which organizes soil into classifications based on its texture and the distribution of sand, silt, and clay. Plant growth is largely determined by climate and soil types. This is because different plants have specific adaptations to accommodate their environment that would make other environments more difficult to grow in. For example, a cactus would not do well in a wet, tropical area, and mangoes would die in a desert. These are extreme examples, but it is a concept that applies to all plants. As I stated before, the soil I am looking at is native to North Texas, especially the Denton area. I chose this because it was an interesting topic due to the proximity. I wanted to know more about the ground that I walk around on every day and what it means for native foliage. In this region, the majority of soil is sticky clay that makes up over 50% of the land from Dallas to Denton. This type of soil often causes foundation issues and cracking in buildings due to how it expands and contracts with moisture. Clay is also a difficult soil for plants to grow in because it's dense and it doesn't let water move through it easily. This can cause water to pool, leading to problems like root rot. As a result, native plants in this area have developed adaptations, like strong deep root systems, to survive. A good example is the red yucca, which has deep tap roots that help it thrive in heavy clay soil. Expansive soil, or silty clay, is any soil that has drastic volume change. It swells when it comes in contact with water, and it shrinks when it is dry. I've included some pictures of both dry and wet clay soil. As you can see, the constant flex makes it difficult for plants to put down roots. In a dry season, the ground gets stretched and becomes brittle, making it impossible for roots to get the correct proportion of water and oxygen that they need. In rainy seasons, the muddy ground drowns the plants because the draining quality is so poor. However, some plants, like the coneflower and the rocky rose, learn to adapt to the harsh environment and take advantage of its high nutrients. I've also included a map that shows the frequency of expansive soil. And as I've mentioned, the Dallas area and the Denton area are high in clay soil. The Houston clay soil developed predominantly from marl and chalk. It was formed in the Cretaceous age, 145 to 66 million years ago. It is made out of a lot of organic material, which means it contains a lot of nutrients. Both chalk and marl are made from organic materials decomposed of life. Clay is one of the most common products of chemical weathering. This type of weathering is caused by minerals dissolving and mixing in ionized water. This breakdown creates very fine-grained particles that make up clay. That is why it is able to hold so much more water than other soil types. This information tells us a lot about what this area might have looked like several million years ago. Evidence suggests that the area was submerged in ionized water. More proof of this would be the fossilizing of aquatic creatures scattered throughout the area. Finally, the taxonomy and the horizons. Soils are classified by their runoff. Class A has the least runoff, and D has the most. They are also classified by grain size. Unconsolidated minerals are represented by two letter symbols based on what type of mineral: gravel, G, sand, S, silt, M, clay, C, or organic, O. And graded or plasticity: well graded, W, poor graded, P, high plasticity, H, low plasticity, L. Versatiles, or clay soil, is classified as soil order. In most soils, there are 6 horizons: O, A, E, B, C, and R. However, clay soil does not have a topsoil that meets the qualifications for O, A, or E, because it doesn't have very much decomposing plant mass or minerals in it. So it begins at the B horizon, which is mostly clay and silt. Thank you for watching my video on dirt. I hope you enjoyed it. These are my citations for all of my information, and these are the citations for the photos.